Today's question number 4 from the sample questions sheet asks, what is the molarity of a solution containing 44.3 grams of lead plumbus perchlorate in 250 mLs of solution? In the question it said 250 centimeters cubed of solution. I just remind you that centimeter cubed is the same as ml, which is the same as cc's, and that 1,000 centimeter cubed is equal to 1,000 ml, which equals 1,000 cc's, and that all equals 1 liter. We start solving the equation by dividing the mass of plumbus perchlorate by the molar mass of plumbus perchlorate. Here's the mass of lead. Here's 2 times the mass of chlorine, because there's a 2 outside the bracket, which means there are 2 chlorine atoms. And 2 times 4 oxygen atoms gives us 8 oxygen atoms, so the total mass comes out to 406. 44.3 divided by 406 equals 0.109 moles of plumbus perchlorate. Then we use the formula, number of moles is equal to molarity times the volume, and we solve for molarity by transposing the V. And we know the 2 values, the number of moles is 0.109 as we solve for here. The volume is 0.25 liters. And we get a molarity of 0.4363, and we reported it to 3 significant figures. The final answer is 0.436 molar. Then we have 2 sample questions here that resemble the types of questions we had in the sheet. The first question is, how would you prepare 2 liters of 0.444 molar strontium acetate? Again, the first step is to calculate the molar mass of strontium acetate. Notice how the bracketed acetate has 2 carbons in it, but because it's multiplied by 2, I did 4 carbons. There are 3 hydrogens in acetate, but there's 2 acetates, so again, 6 hydrogens, and likewise 2 oxygens times 2 gives you 4 oxygens. Total mass is 205 grams per mole. We use the same formula. The number of moles is equal to the molarity times the volume. Here's the molarity. Here's the number of liters of solution we want. We need 0.88 moles. And then we multiply the number of moles times the molar mass to give how many grams of strontium acetate are necessary to prepare the solution. And then we say dissolve 182.669805 grams, or as close to that as your balance will allow, in water and dilute to 2 liters. Obviously, most balances will never reach that level of accuracy, so you would round off according to where your balance's accuracy gave out. There's no reason to introduce extra error, and in some cases it might not be that you need a solution that was that accurate, so you might be able to just say 183 grams if you needed something around that concentration. In the second question we ask, what is the molarity of 39.45 grams of rubidium chlorate in 300 mLs of solution? We take the mass of substance, divide by its molar mass. Again, we get the number of moles of rubidium chlorate in 0.3 liters, because 300 mLs is the same as 0.3 liters. We again use our equation, rearrange it to solve for molarity, enter the number of moles divided by the volume, and we get this value, 0.778 moles. You'll notice that we don't report that as the final answer. There are 4 significant figures here and only 3 there, so we have to limit our answer down to 3 significant figures, and the final answer is 0.778 molar, which is the same as saying 0.778 moles per liter.